All right, welcome back to the channel, talking about more internet computer. In this video, we're going to be talking about the reverse gas model and how it makes it different, how it makes internet computer different than any other blockchain out there. So in order to understand reverse gas model, I think it's important for us to first understand Ethereum and how gas fees work on that network. So on Ethereum, there are gas fees that users pay to have their transactions validated and persisted to the network. So I haven't really used Ethereum or application on Ethereum at all, if I can actually, now that I think about it. But from what I hear, gas fees can be annoying, right? And this can happen as demand for the network goes up. Maybe for some reason, there are a lot of people trying to make transactions on the network. The way the gas fees work is like a bidding system in which validators can choose which transaction to validate based on the fees associated, right? Because these fees are awarded to the validators. So what can happen is demand can become very high and gas fees associated with making the transaction are high as a result. This can incentivize users to change their behavior as they're using the application. For example, exiting a purchase that they were going to make if the gas fees are too high and make the overall cost of the purchase not as valuable to the user, right? So this is what the overall landscape is like across crypto right now, with the exception of Internet Computer. Internet Computer uses something called the reverse gas model, which allows developers to pay for execution and data storage on the ICP network. So with the reverse gas model, the way it works is developers pay for the computation and the storage in something called cycles. Cycles are created when a developer burns internet computer tokens, right? They're converted to cycles, and these cycles are then put onto the canister so that the canister can then use them to pay for any computation and any storage that needs to happen, right? So what are cycles? Cycles are a token on internet computer network that, as I mentioned, are created in exchange for ICP tokens being burnt, right? And the value of a cycle, or the value of 1 trillion cycles, is equivalent to 1 XDR, which is roughly equivalent to $1.33, right? An XDR is an asset that is created by the IMF. From what I understand, it is determined by looking at the value of a few different currencies, such as the dollar, the yuan, and so on, right? So cycles are used to cover the real world cost of operating the node machines. So if we go over to the Internet Computer's website, we can look through the docs and see exactly what kind of costs we can expect if we're building an application on the network. So here we see, quick glance, storage costs roughly $5 per gigabyte per year. Cost per instruction, this tiny number, I can't tell you what number that is, right? Let's look at are these developer docs? Yes, okay. So let's search cycles. Okay, so yes, as I mentioned, cycles are burned by canisters to pay for the resources they consume as execution, storage, and messaging. Fixed price, where 1 trillion cycles is equal to 1 XDR, group of official currencies maintained by IMF. Right, okay. So what are we actually looking for? We want to see cost, and what are things going to cost us if we're building our internet computer? Okay, so yeah, let's start here with Canister Creation. So first thing that you'd be paying for in cycles is to create canisters. So one use case of creating canisters, well, first, to deploy the application, you need to create canisters because your smart contracts will live in a canister, right? So you'll probably need to create a couple of canisters for actually running the application. And then say you have like a social media network or something, or any application with users, right? One solution for implementing users would be to create a canister for each user that joins the application, right? So each time that happens, 100 billion cycles would be burned from the canister's cycle balance, right? Which is approximately 13 cents. So one user, canister, 13 cents to create. This is one way to think of it, right? But canisters there are many other reasons that you want to create a canister. This is just one example that I gave here, right? Next, we have messaging. So canister can receive messages from users and other canisters. So you can think of this as APIs calling each other, right? In terms of canister to canister, you have these two smart contracts that know the language to communicate with the other smart contract. They send messages to one another. These messages have a fixed price, which is base fee base fee is at 260,000 cycles, right? And then you can see here, you add that base fee onto the per byte fee, multiplied by the size of the message or the size of the byte transmitted, right? Which would be 1,000 cycles. And then for user to canister, these are calls that will come from maybe like the client application updating some data on the smart contract or something like that. All right, so that has a base fee of 1.2 mil and 2,000 cycles per byte. All right. So the next thing you could expect to pay for if you're building an application on an internet computer is execution. And the way the cycle cost is calculated is also shown here, right? We have the base fee plus the per instruction fee times the number of instructions, where the base fee is 590 cycles, or this tiny dollar amount, and the per instruction fee is 0.4 cycles. Right, and we have some information here about compute allocation, which I'll let you discover on your own. Right, the next thing is storage. So canisters, they can store data, as I mentioned, and the data is stored either in the WASM memory or stable memory. Stable memory is essentially data that gets persisted across upgrades, and WASM memory is data that is kind of transient and only exists as it is needed, and as such is wiped when the canister is upgraded. All right, so you'll also be paying for storage, and they have, how is it calculated? Storing 1 gigabit, whatever this is, or gigabyte, for 1 second cost 127,000 cycles, which amounts to about 3 billion cycles, or $5 for storing 1 gigabyte per year. Okay, so this is what we saw earlier when we first opened up the docs. $5 per gig per year. Right, and then there's more about memory allocation, which is another topic that I think is great for you to dive into on your own. Right, then the final thing is there are some special features, as they call it. Right, so HTTPS outcalls, which are a means for canisters to communicate with APIs that are deployed outside of Internet Computer, like traditional HTTPS APIs, right? Those have their own costs associated. And then Internet Computer also has Bitcoin integration, which has its own pricing as well. So yeah, everything is here. They have this awesome breakdown of all the fees per operation, like for the different things that you need to do with your canister, and a ton of information for you to discover. So yeah, that's it for now. If you enjoyed, like, comment, subscribe, all the good stuff, whatever you want to do, I appreciate it. And yeah, peace.